when a bridge collapses more than just concrete falls. Imagine the silence after the crash, the gaping void in the middle of the Tocantins River, barges dodging the debris, trucks stopped on both banks, as if the map had been torn in half in place of the continuous crossing between Maranhão and Tocantins. There's an emptiness. Now think of the opposite. New pillars lined up, decks appearing section by section, concrete arms advancing over the water with surgical precision. A project designed to support the weight of the Maranhão region's economy every day, and of those who depend on this crossing to work, study, and live. That's what's happening at the new Juscelino Kubitschek Bridge, the Juscelino Kubitschek Bridge. A fast reconstruction with method after the collapse that exposed the cost of postponing decisions on critical structures. Stay with us for the next few minutes and see how Brazilian engineering is turning a breaking point into an open-air laboratory. From controlled demolition, successive cantilever construction, and the rebuilding of one of the most strategic connections between the North and Northeast. The whole story centers on a very specific point on the map. The Brazilian Federal Highway 226 crossing the Tocantins River between Guiarnópolis in Tocantins and Estreito in Maranhão. That's not just a state border, it's a powerful economic connection. Anyone coming from the interior of Maranhão towards ports and consumer centers passes directly or indirectly through this crossing. When this hinge locks the highway axis, you feel the new Juscelino Kubitschek Bridge is born to break this hinge at another level. It is 630 meters long, about 100 meters longer than the original structure, and 19 meters wide. On this deck, there are 2 lanes, 2 shoulders, New Jersey-type barriers, and 2 side walkways protected by guardrails. The central clear span reaches approximately 154 meters, providing more space for navigation on the Tocantins River without relying on pillars in the middle of the main channel. It's worth noting that this set is not there for aesthetics. It's a direct response to a logistical bottleneck that, when it failed, brought trucks, buses, ambulances to a halt and disrupted the daily life of 2 entire regions. To understand why this new bridge had to be built this way, we need to go back to the structure that was there before and see what happened when it could no longer hold up. In 1961, Brasília was still a newly founded capital, and the Belém-Brasília highway cut across the map like a new axis. Brazil was betting that asphalt could stitch entire regions together. In this context, the first Juscelino Kubitschek Bridge was built, connecting Estreito to Guiarnópolis. With just over 530 meters and a central span of pre-stressed concrete, which was impressive for the time, it became the local Brasília, a symbol of integration, a fixed landmark in the mental map of truck drivers, interstate buses, and motorists. For decades, it was the sole direct road linking Maranhão and Tocantins there, but the surroundings changed faster than the bridge. Trucks got heavier, the traffic increased, and the operation became almost continuous. Technical reports began noting cracks, exposed reinforcements, support issues, structural alignment, and attention levels. There was a bidding study for the recovery, but documentation and qualification obstacles pushed the solution further ahead. On December 22, 2024, the warning became reality. The central span collapsed, taking vehicles with it. Trucks, cars, and motorcycles fell into the river, including 2 trailers loaded with sulfuric acid and pesticides. The collapse caused a maximum alert for possible Tocantins River contamination. The National Water and Sanitation Agency stated that 76 tons of acid potentially came into contact with the river. Several municipalities suspended water intake out of concern, while later reports indicated that the tanks remained intact or had controlled leaks. The tragedy left at least 14 people dead and others still unaccounted for. The emergency alternative was a ferry system with temporary exchangers on both banks. The crossing continued, but with lines, waiting, and an operation sensitive to wind, floods, and the availability of vessels. Given this scenario, the technical question changed in scale. reinforce an old and limited structure, or rebuild everything with a different standard for span deck foundations and monitoring? The answer came in the form of an emergency contract of about Brazilian, real 172 million and an aggressive deadline of 12 months. In fact, it's from this commitment that the story leaves the drawing board and enters the construction site. Dismantle, lay the foundation, and gradually build the new Juscelino Kubitschek Bridge over the Tocantins River. The new Juscelino Kubitschek Bridge is no longer just a set of project blueprints. About 75% of the work has been completed, and all 24 foundations and 26 pillars are ready. The 45 precast beams for the access ways were cast in the yards and installed. The deck, constructed with successive cantilevers in the central span, has already advanced with many segments from the main supports. Delivery is scheduled for December 2025, within the emergency timeline set after the collapse. But before any new meter of concrete could be poured, it was necessary to carefully dismantle the past. After the collapse, part of the old structure remained standing, tilted, and cracked, posing a risk to navigation and to the construction itself. Leaving that there was not an option. The solution was a controlled implosion using over 200 kilograms of explosives placed at key points on the pillars and superstructure, with a timed detonation sequence to bring it down in the intended direction. In seconds, the old bridge turned into dust and rubble in the riverbed. After the evacuation of nearby houses, a total roadblock, and the suspension of navigation, the implosion generated about 14,000 tons of debris. Next, riverbed cleaning started. Barges, cranes, floating platforms, excavators, and smaller vessels removed blocks by cutting steel and clearing the corridor where the new supports would be installed. Part of the demolished concrete was reused for embankments, construction access, and platforms on the banks. The surplus was sent to Botafogo, which is environmentally licensed. With the riverbed prepared, the foundation stage began, always competing for space with the current, changing water levels, and short windows of good weather. The 24 deep foundations were built by excavation, underwater, and concreting underwater, forming capping blocks anchored in competent soil. Every level, every measurement, everything was checked because any deviation here will show up amplified in the successive cantilever. On top of these blocks, 26 columns were built, designed to support both the access beams and the pre-stressed deck of the main span. As they rose, the silhouette of the new bridge began to shape the horizon again, now with a different outline. For the approaches, the classic solution of precast beams was used. The 45 pieces were produced on site in metal molds and lifted by large cranes. Even for the supports in precise operations in the central span, the protagonist is the engineer of the balanced cantilever method. Starting from the main pillars, the deck advances in segments. Each concreted or assembled segment receives pre-stressing cables that tie the structure together, and only then is it released. Next step, a segment on one side, a segment on the other, maintaining the balance of forces, high precision surveying monitors, deflections and displacements, and deformation readings confirm whether the behavior matches what was expected. The final meeting of the cantilevers, in the middle of the span, turns weeks of work into a joint of blocks measured in centimeters, adjusted with jacks and high-strength grout. With the structural deck closed, it starts to become a road. Pre-slabs are placed over beams and segments, and the final slab includes drainage niches and energy ducts. Then comes the waterproofing bonding layer and rolling asphalt, all designed for continuous heavy traffic. On the construction sites, New Jersey barriers and metal guardrails appear, separating vehicles and pedestrians and making future inspections easier. While all this is happening, the temporary crossing continues by ferries, with 4 exchangers operating continuously and lines organized by vehicle type. Each meter of concreted deck is one less step of dependence on this emergency arrangement, and one more step toward a continuous road crossing compatible with the role of this point in the country's road network. If you look at the new Juscelino-Kubitschek Bridge on a road map, it just looks like a small line crossing the Tocantins River. But just zoom in on its function to realize that this line acts like a circuit breaker. Switched on. The north-northeast corridor flows disconnected. Trucks, buses, and ambulances stop on both banks, waiting for a solution. It doesn't compete in size with giants like the Rio Niterói, with its more than 13 kilometers in length. K is only 630 meters long, that is, 4.8% of the Fluminense Bridge. But translated to our everyday scale, that's equivalent to almost 6 soccer fields lined up over water, supporting every day the combined weight of an entire fleet of loaded trucks. The width of 19 meters puts the deck in the same range as 2 urban avenues combined, complete with lanes, shoulders, and sidewalks. Now, another impressive number is the free span of 154 meters. Do you want to get a sense of what that means? In that space, it would be possible for 2 sea-wise giants, the largest ship humanity has ever put to sea, with an impressive width of 68.6 meters to pass side by side. In the budget, the project amounts to 172 million reais. That's enough money, for example, to buy about 190 new city buses, or to build between 9 and 12 medium-sized public schools. Depending on the construction standards adopted, the budget for the new Juscelino-Kubitschek comes close to what's needed to restore dozens of kilometers of simple highways with complete pavement, drainage, and signage. Here, however, all that investment is concentrated in 630 meters of highly specified designed centers, so that a structural failure like the one in 2024 doesn't once again paralyze the connection between Maranhão and Tocantins. With the completion of the new Juscelino-Kubitschek Bridge, the main benefit is directly ending the dependence on ferries at a strategic point on the Brazilian Federal Highway, 226. What today requires waiting in lines, boarding, crossing, and disembarking will become a continuous stretch of road. Trucks reduce unproductive stops, fuel consumption decreases, fleet wear goes down, and freight becomes more competitive. Grains, meat, industrial supplies, and goods in general cross Tocantins with more predictability and lower costs for the local population. The bridge brings back daily life without the river factor. In regional planning for the future, the project strengthens the highway corridor and integrates Tocantins, Maranhão, and other states of the Matopiba region and other economic hubs. And it creates a more robust physical foundation so that the region's recent growth is not left vulnerable. At a single point of structural breakthrough, the new Juscelino-Kubitschek Bridge synthesizes a complete cycle of infrastructure, a work from the 1960s taken beyond its limit. The collapse with victims and regional impact, the controlled demolition, the emergency contract, and the reconstruction at a new level of capacity, geometry, and monitoring. More than just replacing a crossing over the Tocantins River, this bridge embodies a technical lesson, that of maintenance. It comes at a high cost, and responding with method, data, and planning is the only way to prevent a failure point from suddenly shutting down an entire corridor of the country again. Thank you for watching this video up to this point. Were you aware of the process and progress of the Juscelino-Kubitschek Bridge, and what are your views about it? Also, leave your criticisms here. If necessary, I'll stop here. A big hug and see you in the next video.